Hello guys, you're welcome back to the reaction zone. In today's lesson, we're going to look at the characteristics of electrovalent compounds. The first one is that electrovalent compounds have a crystal lattice structure. In electrovalent compounds, they have a geometrical arrangement of the ions in the solid. In these compounds, there is a three-dimensional arrangement of the ions. Not just that, the ions are arranged in a regular pattern, giving rise to a lattice structure. For example, this diagram here shows the crystal of sodium chloride. Sodium chloride has a cubic lattice. And in this cubic lattice, each sodium ion is surrounded by 6 chloride ions. Also, each chloride ion is surrounded by 6 sodium ions. For example, look at this sodium ion here. It is surrounded by 6 chloride ions. 1, 2, 3, 4, 5, and 6. The second characteristic of electrovalent compounds is the fact that they have high melting and boiling points. In an electrovalent compound, the ions are held by strong electrostatic forces of attraction. These forces of attraction are not just strong, but they hold the ions in fixed positions. And to break these forces of attraction, a large amount of energy is required. This is the reason why electrovalent compounds have high melting points as well as high boiling points. For instance, sodium chloride, NECO, has a melting point of 801 degrees Celsius and a boiling point of 1413 degrees Celsius. The third characteristic of electrovalent compounds is that they are hard and brittle. Electrovalent compounds are hard as a result of the strong electrostatic force of attraction that holds the ions together in the lattice. However, they are also brittle, meaning that they can break easily, especially when an external force or an external pressure is applied. When an external force is applied, what happens is that the layers of the crystal move and may come in contact with each other in such a way that like ions are brought in contact. And when like ions, what I mean by like ions are, for instance, sodium ion and sodium ion brought in contact, or chloride ion and chloride ion brought in contact with each other. When like ions are brought in contact with each other, what happens is that there will be a repulsion. And this repulsion is what eventually leads to the breaking of the crystal. So, despite the fact that electrovalent compounds are hard as a result of the strong electrostatic force of attraction, they are also brittle when an external force or pressure is applied, bringing the layers of the crystal in contact with each other. And when like ions face each other or come in contact, the repulsion between them leads to the breaking of the crystal. The fourth one is solubility. Electrovalent compounds are soluble in polar solvents, like water, but they are insoluble in non-polar solvents like benzene and ether. Polar solvents like water have a very high value of what is called dielectric constant. Dielectric constant. The dielectric constant of a substance is simply a measure of the ability of that substance to reduce the electrostatic force of attraction between oppositely charged ions. The greater the value of the dielectric constant of a substance, the more easily electrovalent compounds will dissolve in that substance. Now, looking at this table here, this table shows us the dielectric constant of certain compounds: water, methanol, ethanol, propanol, and ether. The value for water is 81. The value for methanol is 35. The value for ethanol is 27. The value for propanol is 21. And the value for ether is 4.1. Now, when you look at the values of the dielectric constants of these compounds, water has the highest, and the least value is for ether. So from this table, we can infer that electrovalent compounds will dissolve readily in water because of the high value of its dielectric constant, but will not dissolve in ether because of the low value of its dielectric constant. Now, non-polar solvents generally have low values of dielectric constant, which is what makes it impossible for them to dissolve electrovalent compounds. The last characteristic that we're looking at is electrical conductivity. Electrovalent compounds in the solid state are incapable of conducting electricity. This is because of the strong electrostatic forces of attraction which holds the ions in the lattice in fixed positions. In other words, making it difficult for them to move. However, when an electrovalent solid is melting, that is when it is in molten state, or when it is in solution, the ions are free to move about. So, on the passage of electric current, these ions in solution can move towards their respective electrodes. So, this means that in the solid state, electrovalent compounds cannot function as electrical conductors. That is, they cannot function as electrolytes. But in the molten or in the liquid state, when they are in solution, they are capable of functioning as electrolyte or as electrolytic conductors. I want to believe that the explanation for the characteristics of electrovalent compounds is clear. Thank you very much for watching, and see you in the next class.